Good afternoon. So last class we discussed about the chemical properties of the aryl halides. So among of them there is one more reaction. Reduction. If aryl halide, for example, chlorobenzene, reduction with the zinc copper in alcohol convert into benzene. So chlorobenzene on reduction with lithium aluminum hydride also, a strong reducing agent, or zinc copper in alcohol. Alkyl halides are converting into alkenes. Similarly, aryl halide is also reduced to the benzene. One more, a condensation reaction of chlorobenzene, that is formation of the DDT. It is acetaldehyde. When this acetaldehyde treating with the chlorine, excess chlorine and chlorination, this alpha hydrogen can replaceable by the chlorine atom converting into trichloroacetaldehyde, which is known as the chlorol, or trichloroacetaldehyde. If this chlorobenzene condensed with the chlorol can form the DDT. Can form it is what the DDT. With respect to this carbon, it is the fourth position, or maybe called as the para position. It is also para. So the name of the compound is para dash dichloro diphenyl trichloro, because there are three chlorine atoms. How many carbons in this now? Two. So when chlorol or trichloroacetaldehyde condensed with the chlorobenzene can form the DDD, dichloro diphenyl trichloroethane is formed. So these are some other chemical properties of the chlorobenzene, aryl halides. One is reduction, second one is the condensation reaction with the chlorine. Reduction of the chlorobenzene can form the benzene, that is aromatic hydrocarbon, and condensation can form the DDT. Okay, so write down reduction. Chlorobenzene on reduction. Chlorobenzene on reduction. Zinc copper in alcohol. Zinc copper in alcohol, or lithium aluminium hydride. Lithium aluminium hydride gives benzene. But the chemical reaction? Next, condensation reaction. Chlorobenzene condensed with the chlorobenzene condensed with the chloral or trichloroacetaldehyd in presence of concentrated sulfuric acid in presence of concentrated sulfuric acid and forms DDT. DDT. Try the reaction. What was the IUPAC name of this? It's a commonly we can call as dichloro, that is para dichlorodiethyl trichloroethane. And what is the IUPAC name of this compound? Anybody of you? It is first carbon, second carbon. Because there are three chlorine atoms. You give the numbering for this carbon 1 plus 1 plus 2 plus 2 plus 2. 8. So it is 1 plus 1 plus 1 and 2 plus 2. 7 of them. So coming numbering for the chlorine atom, get the least possible number. So come to this. At second carbon there are two non. What is fourth position of the chlorine containing of benzene? So if a substituent is in the bulky nature or a complex substituent is present on the given parent chain more than one time, we use as not dinon, bis. So IUPAC name of the chloroalkyl. DDT is nothing but the 2,2 bis. What position it is now? 4 chlorophenyl 1,1,1 trichloroethane. It is the IUPAC name of the DDT. 2,2 bis 4 chlorophenyl 1,1,1 trichloroethane. Next, write one question. No? Predict the alkenes. Predict the alkenes that would be formed. That would be formed in the first write in the question, then I will explain them. That would be formed in the following reactions. Following reaction and identify the major alkene. Identify the major alkene. So look once again for the IUPAC name of this compound. Commonly it is known as the dichloro-diphenyl trichloroethane. In case if a substance is complex in nature or bulky in nature, present on the parent chain, then the name of the complex compound must be written in the bracket. If it is present more than one time, then it was written as the, instead of di or tri, we can use as bis for 2, tris for 3, tetrakis for the 4. For the commons, for example, if it is a compound like this, 1, 2, 3, 4, 5. Now it is just 2, 3 dimethyl pentane. Because the substance presence on 2 times. In case if the compound is like this, one, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Now these two are complex compounds. Present at third position as well as the fourth position. It is first carbon, second carbon. Now it is also 2 times, more than 1 time. It's a complex compound. That is, at first carbon there is a methyl group and it contains 2 carbons, methyl ethyl. So in such cases, if a complex substance present more than 1 time on the parent parent hydrocarbon, it was named as the 2 for bis, 3 for tris, 4 for tetrakis. We can't use di and tri. Okay. When the complex compound is more than 1 time, then we can use bis, tris, and tetrakis. For common substance, that is normal substance or side chain, we just use di and tri. The name of this compound name is nothing but the at 3, 4. Bis, bis means 2 times. What it is? Methyl, ethyl, octane. Bis, because this complex substituent present more than 1 time, so we can use as a bis. Methyl and 2 carbons, ethyl. Similarly, in this case, this chlorobenzene present 2 times on the second carbon atom. If numbering from this carbon, for example, if it is number 1 and 2, 1 plus 1 plus 2 plus 2 plus 2 is equal to 8. If number in such a way, 1 and 2, 1 plus 1 plus 2 plus 2 is equal to 7. So it was wrong, it was correct. So at second position, there are 2 complex compounds, which is at para position 1, 2, 3, 4, fourth position. It is also fourth position. 2, 2, bis, 4 chlorophenyl, 1, 1 trichloroethane, 2 carbon atom. Okay. So it is the IUPAC name of the DDT. In olden days, it was used as a germicide as well as fungicide. Nowadays, it was banned because using of this, some side effects will be arising. That is, cardiac effects will be arising, so that it was banned. But in olden days, it was used as the fungicide as well as the germicide, DDT. Okay. So come to the question. So textbook question, no? Predict the alkene that would be formed in the following reactions and identify the major alkyl. Bromine CH3 reading with the sodium ethoxide in ethyl alcohol. Second one, 2-chloro 2-methyl butane. Treating with the again sodium ethoxide ethanol. It's come under the elimination reaction. General elimination reaction followed by the Sitzapfel, whether E1 mechanism as well as the E2 mechanism. Right? So sodium ethoxide, that is Na plus OET minus. So it's a strong nucleophile as well as the base. So strong base are used for the E2 elimination. That is via formation of the transition state. In that it is contains 5 atoms in one plane. So if it is using by the sodium ethoxide followed by the E2 mechanism, with respect to this, it's an alpha carbon, beta carbon, beta carbon, it is also beta. So B1, B2 is same and B3 is different. According to elimination reaction, Fitzgerald product is the major one. So it gives two products. Among of the one is nothing but the methyl cyclohexene. And second one nothing but the removal of the hydrogen from the beta 3 carbon atom. Methylene cyclohexene CH. It is major product. Endo product is major and exo product is the minor. In this case, it is also beta carbon, it is also beta carbon. So as per the elimination reaction, both can be followed by the Fitzgerald. That is more substitute alkene is the major product. So in this case, the product is, it is also beta now. Plus if you remove this one, you get same product. So in this case, it has the more number of alpha hydrogens. 3 plus 3, 6 plus 3, 9 alpha hydrogens. In this case, with respect to this 3 plus 2, 5 alpha, it has 5 alpha hydrogens. It contains 9 alpha hydrogens. So which is major now? This product is major. So this was the answer for the questions. So 1 bromo, 1 methyl cyclohexane treating with the sodium ethoxide followed by E2 mechanism give the Fitzgerald product is the major one. Similarly, 2-chloro 2-methyl butane treating with the sodium ethoxide again followed by E2 mechanism can give the 2-methyl 2-butene is the major product. Write the answers. Next question. Draw the structures of draw the structures of major monohalo products. Draw the structures of major monohalo products in each of the following reactions. In each of the following reactions. To try these questions, These six reactions are related to the preparation of alkyl halides. Actually, it has to be given by the reagent. Pyridine associate thionyl chloride in pyridine. So it's an SN2 reaction. Alcohols convert into chloro compounds by Darjan's process. Give the chlorocyclohexane. It is Darjan's reaction. Better method for the preparation of the chloroalkanes. Next one. Br2 by heat or sunlight. Bromination is an free radical substitution reaction, FSR reaction. Free radical substitution reaction means at the alkanes only it can make the reaction. Among of these two, it is a methyl group, that is primary carbon, and it is benzyl carbon. The reactivity in the halogenation Benzylic more than the allylic, then 3 degree, then 2 degree, then 1 degree. So here is the place where bromination can be take place. CHBr, CH3 and OH. And come to this one. Now both are OH groups. It is an aromatic alcohol, phenol compound. It is an alkyl, so alcohol compound. Alcohols are readily participated in the reaction comparing with the aryl alcohols. So benzyl alcohol convert into chlorine, not of the aromatic compound. So this OH group involved in the reaction. They donate the electron to this H plus ion, removed in the form of water molecule and forms carbocation. Upon that, chlorine atom attack on the carbocation, that is benzyl carbocation, converting into benzyl chloride. Next, you better know this reaction. In this case also, we use a solvent known as the acetone. What name reaction it is? It is converted into CH3CH2I. Finkelstein reaction. Converting of chloro or bromoalkanes into iodoalkanes by treating with the sodium iodide in acetone. Next, an alkene addition with the HI. Alkenes mainly participate in the electrophilic addition reaction. In that case, it proceeds to the formation of carbocation. That was the product. If you look at the mechanism for this case, addition of H plus ion, it forms a carbocation, that is 2 degrees. Going off rearrangement, 1, 2 hydride shift. So these are the intermediate formed in the reaction. And come to sixth one, bromine. If only giving by bromine, it will give the dihalides addition reaction, but it is given in presence of sunlight. Any halogenation in presence of sunlight will follow the FSR, free radical substitution reaction. So in that case, it forms the product. At allylic position. These are in-text questions of your textbook. So there is a possibility to ask in the IPE. Okay. Note down. Next, identify A comma B comma C comma D comma E, A comma B comma C comma D comma E comma R and R dash R dash in the following reactions. In the following reactions. Bromocyclohexane treating with the magnesium in presence of dry ether gives anal. A on hydrolysis can give B. RBr reacting with the magnesium in presence of dry ether gives C, which on deuteralysis sodium by dry ether can form two comma two, 3 comma 3 tetramethyl butane. On treating with the magnesium in dry ether can give D, on hydrolysis can give E. So you have to find out the A, B, C, D, E, R and R dash. Take your time, try yourself. look at in this case now. What is A in this compound now? Alkyl halide react with the magnesium. Dry ether can form Grignard reagent. That is cyclohexyl magnesium bromide. On hydrolysis, B can form the cyclohexane. Now C on hydrolysis you are getting the product. So C is again Grignard reagent. C. So what is in this case R none? Propyl bromide. R dash X. If you make them into two parts, that is so come to the D is nothing but the a Grignard reagent and E of the product is nothing but D. Two methyl propane. Hello? Next, one more, no? In the following pairs of halogen compounds, in the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? Generally, SN1 reaction, the rate of SN1 reaction is 3 degrees more than 2 degree, then 1 degree. Of alkyl halide. So come to this case, it is a 3 degree alkyl halide, it is 2 degree alkyl halide. So among the first pair, tertiary butyl chloride is faster than the 2-chloropentane. 3-chloropentane. And come to in this case, it is 2-chloropentane, it is 1-chlorohexane. So which is major? 2-chloropentane is major than the because it is the rate of SN1 of alkyl halide. 3 degrees more than 2 degree than 1 degree. In case of rate of SN2 is opposite to this, 1 degrees methyl halide is more than 1 degree, then 2 degree, then 3 degree. Remember this. There is a possibility to ask a question of 2 marks level. They give one pair to you, identify which is more. Okay. So these are some in-text questions for the alkyl halides. So it is about the halogen derivatives now. That is alkyl halides and aryl halides. And tomorrow we start the new chapter, that is oxygen containing compounds 1. Alcohols, phenols and ethers. Okay.